Okay, so now the background is blue, but the other thing that this code did is this rather complicated, and I won't explain it all quite yet, piece of code. But the important part here is it called a function called new segment within the wall module. And it's going to put the segment at position X, Y, which we've calculated above. I'll explain this later. It says make the segment at a minus 45-degree angle, which is what this argument is. And then it's going to give it a length of first length, which is 200, and a path width, which is 100. So it's going to be 200 pixels long, 100 pixels wide. Now, clearly what we're showing here is a line. So let's start to break down the code and see how to make this line be something more useful. One of the first things I discovered when I did this was the easiest way to draw a hallway is to draw something, center it, and then return a couple of values that tell me where the end of that segment was. So when I draw my next segment, that I can simply start from that point. Because this is an endless runner. What's going to happen is we're going to be producing more and more hallway segments as we go along. So we need to know where the end of the last hallway segment was. So we can create our next segment right there, and then more and more and more, always advancing. So the first thing we do, and this is really complicated seeming, but it's relatively straightforward once you understand the principle. I took a function called angle to vector fast, which comes out of the SSK Corona libraries. And I'm not going to show you how it works today because we can do a discussion of 2D math in the future. But basically what this function does is it converts an angle into a vector, a unit length vector. Now, a unit length vector, for people who don't understand this, is a vector whose length is 1. And the reason a unit length vector is important is because we can then use that in all kinds of interesting ways. For example, for people who understand 2D math, we can take a unit length vector and convert it into a line segment, in a sense, by multiplying it by a value of, say, 5. And that would say this line segment is now 5 in length. It's a nice malleable vector that we can choose the length. I'm not doing a very good job. I'll just walk through the code. How's that? So angle to vector, I take the angle. It's going to return an x and a y, which represent the vector. I'm going to use another function. I'm going to pass those x and y values in, which I call vx and vy, and a length argument. Now remember, I had a length of 200 pixels. So what this is saying is create for me a vector whose length is 200 pixels. And the angle of that vector is 45 degrees to the left, minus 45 degrees. So that's what we have at this point. Now the only thing we have to do is position it. Now people who are listening to this who are not familiar with 2D math, just bear with me, but those who are familiar will understand that the way that you position a vector in any world view is simply by taking the vector you have and adding a value to it. So our vector at this point is, you can consider it positionless. It's merely a length. But by adding the initial x and y to it, what we're saying is move this vector to that place in the world. And then finally, after all this, I can draw a line that starts at x and y and ends at vx, vy. So all of that work was basically to take this point here and draw a line 200 pixels to the left and up so that we had this little endpoint right here where my cursor is going around on the screen, which is what you're seeing. So for example, if I made this length or width 4, you see that that's the line that we just created with this code. Now I just made it a little bit thicker, just so you could see it in the demo. So not very useful. However, let's go back to the game and let's uncomment the rest of this code here. I'm not going to explain too much what it's doing, but what it's doing in a nutshell is it's drawing a segment, it's returning this last position right here, which then we will pass in as the next argument and tell it to draw from here at a certain angle for a certain distance, and when you're done, return the position of the new end of that line. So every time it draws a line, it's going to return the last position of this, basically you could consider as like the dot that would go there. So let's let's save that. Now what we've got is a 4-segment line. We can't see it all because it extends off the screen, but we got 1, 2, and 3, and then this last segment is off of the screen. So I could theoretically just do this. So now we got progress. Now we've got a zigzagging path of sorts, but it's completely useless to us because there's no walls. There's not really a path, but it gives us the outline of what we need to do. It was this point that it occurred to me that the easiest way to make this work is, now that we have these segments, I can find the middle of every segment. We're doing just a little bit of math, and then I can place a rectangle here and rotate it, a rectangle of the correct length, and rotate it, place another one in the middle of this segment, rotate it to the right, this segment, rotate it to the left, and as long as they have the right length, what I will have is rectangles that are over the position of these lines, which is what this next piece of code does. So this is step 1 of making the walls, of understanding how we make the walls. So I'm going to uncomment line 59, and then the math that I'm doing here is basically, what I want to do is calculate the center. And calculating the center of a vector is as simple as taking the 2 components, Vx and Vy, and then subtracting the position offset, dividing that value by 2, and then adding the position value back. So what I have done mathematically is, a vector defines a direction and a position, but I want to take the position part out while I'm trying to find the middle. This is not a math class, so just trust me that what you have to do is move it to the center of the world, in a sense, is what we're doing here. We're taking the positioning out by subtracting x and y, which is from here, taking that resulting value, dividing that by 2, splitting it in the middle, and then removing it back to where we want it, the offset, in a sense. And what that produces is the position of the center of this line right here. Then I say, create a new rectangle, put it in layers content 2, which is our middle layer in the world, place it at mx, my, which is the center position here, make it 4 pixels wide, that's just an arbitrary value that I chose, and make it as long as the segment is supposed to be, and then rotate it by the angle. If I did not rotate it, this is what we would get initially. It's a bunch of rectangles, very thin rectangles, centered on these lines. But simply by rotating them, now we got a bunch of rectangular segments. I'll make this a little bit bigger so people can see it. Rectangular segments which overlap perfectly the line that we just drew. Now we're getting somewhere. Now we got like 1/2 of our wall. It occurred to me, well, it occurred to me before I did this step, but that once you've done this, once you've solved this problem, I'm waving at the screen like people can see me, all you really got to do is create 2 rectangles and then move one to the left by a certain amount and one to the right by a certain amount, and you'll get a hallway. So to prove that out, I'm going to comment out these 2 bits of code. That drew just one wall. I'm going to go here to line 69. I'm going to enable this bit of code. I'm going to use the mx, my from our last, which is, it's the center piece here. Let me move, come on, get out of the way. It's the center bit here. I'm going to create 2 rectangles that initially will be right here, but then what I do is I move one over by 1/2 the width of the hallway to the left, and I move the other one to the right by 1/2 the width of the hallway, so that in a theory we get the whole width, correct? They're still 4 pixels wide each, and they are the same length. Let me take this bit out. Same length as they were before. So let's do that. Oh, and then I rotate them both by the same amount. And if we, let me make sure that's saved. If we run that now, Now we have our original line, which showed what we were trying to achieve, but now it's starting to look like a hallway.